In this video, I'm going to show you how to compute in MATLAB a system of coupled recurrences. Okay, so here instead of having one recurrences that governs the behavior of one sequence, okay, for example, to model the growth of a population, okay, well here we are going to have two populations which interact, right? And therefore the recurrence relation that we use for the evolution of one population is going to depend on the behavior of the other population and vice versa. Okay, so the best thing to do is to take an example. Here we consider this system of coupled recurrences. Okay, so we have two initial conditions now, okay, for A and B, the two sequences that we consider, right? And we have AN, which is the equation that governs the evolution of the sequence A, which now depends on Bn-1. Okay, so the evolution of the population B, and similarly the evolution of the population B depends on An-1. So the two equations here are coupled, right? They are said to be coupled. So how do we compute this thing in MATLAB and then plot the results? All right, so first let me access the folder. Okay, and I'm going to create a new function. I'm gonna call this function for example coupled recurrences. Okay, I don't want any input arguments because I'm going to define all my commands inside the function, and I don't need any output arguments as well. Okay, because all I want to do is plot the two sequences at the end. Okay, and here we just compute system of coupled recurrences. Okay, so what do we do? Okay, we want to compute that. Well, similarly as for the single population growth models, okay, we need to define a maximum n. Okay, we're going to compute up to some n. Okay, so let me define that as a new parameter and call it capital N. So say maximum time, if you assume that n represent the evolution of time. So maximum time is capital N. Okay, and let me take, for example, 500. Okay, we'll see. We can change that later if it's if we can't see anything in that time frame. All right. Then what we want to do is initialize the two arrays. Okay, both A and B. So we define initialize, and we define an array A. Okay, and how do we initialize in MATLAB? Using the command zeros. So zeros, which will have size, well, exactly 500, capital M. So 1, capital N. Okay. Then I do the same thing for B. B will have the same size. Okay. And then I need to write the initial conditions. Okay, so A1 and B1. And of course I do these outside of the for loop, as was done for the single population growth model. So A of 1, okay, what is that? Well, we said it was 500. Okay, let's take 500, and B of 1, we said it was 215. Okay, so really the steps are exactly the same as when I compute a single variable recurrence. Okay, except I repeat them. Okay, instead of defining one array, I define two arrays. Instead of defining the first value of one array, I define the first value of two arrays. And now when we actually compute the recurrence, okay, and fill up the arrays with the elements of the sequence, well, we are going to use a for loop, but at each step of a for loop we need to define both A and B, or A of n and B of n. So for n equals 2 to capital N, remember we start at 2 because we've already defined the first value of the two arrays, okay, here. And then we define A of n, the nth entry of the array n, which corresponds to an, that value here, okay, is given by this relationship, right? So all we have to do is write that. So that was 1.01 times an minus 1, okay, minus 0.02 times b of n minus 1. Okay, and now on the next line I define the recurrence for b, so b of n, which is equal to, okay, 0.2 an minus 1 plus 0.99 bn minus 1. 0.02 times an minus 1 plus 0.99 times a of n minus 1. Oh, b, sorry. Okay, so I have simply written here my system of recurrences, okay, and you may wonder, well, how can I calculate a here while b has not been defined? Okay, so I calculate a in terms of b in this first equation here, but I haven't defined b. Well, you have, because it's going to, for example, when n equals 2, okay, then we're gonna need b of 2 minus 1, which is b of 1, and b of 1 has been defined at the previous step, which is here outside the loop, okay? So that's all good, right? So you could actually change the order of these two equations and it won't change a thing, okay? So once we have defined our system of recurrences, then we can plot the result. So plot. Now be careful here, because I want to plot the two sequences a and b on the same figure. So how do I plot two sets of arrays on one figure? We've seen that. Well, we also need to define the x-coordinate arrays. Okay, so here we want to plot the values of a and b against the integers from 1 to capital N, 1 to 500. Okay, so I need to define an array containing these values. So let's call it, for example, xvals equals an array containing all the integers from 1 to 500, or 1 to capital N. So that's simply 1 colon capital N. Okay, that's how we do it in MATLAB. Now that I have defined these x-coordinate values, right, I can plot, well, the array A in terms against these x values and the array B against these x values. So remember, when you plot several arrays in one figure, okay, you start by entering the x-coordinate array, so xvals, then the y-coordinate array, which here would be a, okay, so we plot a against xvals, and then we can add some options. So for example, the first one would be in blue, okay, and then I use xvals, okay, to plot my second set, my second array b against xvals. So it's xvals comma b comma some options. For example, let's do that one in red. Okay, and I close the bracket. So that should work. Okay, let me save that. Okay, let me go back here. Okay, and I'm gonna call now coupled recurrences. And there you go. Well, that's quite interesting, okay, because see, we have actually some oscillation. Okay, so it seems that the evolution of the population is going to be periodic, right, for this particular case. Now, does it always work that way? Well, we can take a longer time and see if it works. So for example, if instead of 500 I take 5,000 time steps, okay, something much longer, save, go back here and call the same. See, actually it's not exactly periodic, okay, it seems that the population grows slightly, okay, it oscillates, but at the same time it grows. All right, so it's quite an interesting recurrence, system of recurrences. Okay. Now in another video we will see a problem, a real life problem, which involves the interaction between two populations, the prey-predator model.